So, what do you know about Docker so far? What is Docker? Yeah.
It's kind of like a VirtualBox, but not like that. More like
Mm.
raw version of it.
Yes. Like mm. Anyone else? What does VirtualBox do differently to virtual machines? Are VirtualBox this? I mean, VirtualBox. Sorry. Is Docker the same thing as virtual machines? No. What's different?
They all run on the same kernel.
Yes. So they all share the same file system, like not really, but kind of. They all share the same system resources, not really, but kind of. And they all run in the same like process hierarchy. Okay. But not kind of. But yeah, kind of not. So exactly. So normally when you have a virtual machine, you have a host operating system and then some hypervisor, for example, a VirtualBox that you have used before, maybe. And then you have your guest OS the same way you have, so say you're running Ubuntu on your Windows machine. Then you have your host operating system, that's your Windows machine, and you have your guest operating system, that is your Ubuntu, Ubuntu system. Then you want to run something on there, so you need all your bins and libs to actually, like all your libraries and dependencies for your application. And then you have your application on top of that. But in the case of Docker, you only have one operating system. So you only have whatever you run on, and then you have your Docker engine on top of it, and you have your bins and your apps. What do you think the advantage of doing it this way might be? What do you save on by only having one operating system? Yeah.
Resources, like memory and
Yep.
and overhead for processing.
Exactly. So what's the benefit of using that, for example, when you're running a server? What do you get for using Docker?
It's a lot quicker to spin up just another the container.
Exactly.
Than it is to boot up an VM.
Exactly, have scalability on demand. So with the Christmas example, right? So traffic goes up around Christmas. You just spin up like a few more Docker containers to deal with it. Very easy to do that. Let's see, what more? Right. Are there any disadvantages of doing it that way then? I'm sure you can think of some. So what's the downside of having all of them share? Oh, sorry.
It's less secure.
Yes, exactly. So it's less secure because all of your processes are actually running on the exact same system, sharing the memory, and among other things. So it's easier for some malicious code to get to other resources from other Docker containers or other anything really. It's just easier to do it. When you're on a virtual machine, like an actual virtual machine, you don't have that like freedom to actually go between it because it's just like memory and it's slotted off completely. So you only affect your machine. You can't go and mess with other virtual machines. Yeah.
Unless there's a bug.
Unless there's a bug, yeah, exactly, but those are harder to find. So yes, exactly, they are more scale up on demand. You can just spool them up when you need them. You can just like make more Docker containers because you have your image. You don't have to set up another virtual machine. You don't have to like have a drift person come and like do that for you. Docker can just like you can set up like Docker Swarm. I think it does that for you. Yep, and then you can just have the capacity that you need. And in the case of like, what they're called, goddamn, providers, then you only pay for the amount of computation you're doing, right? So if you don't use many containers and you're not using a lot of CPU time, you don't pay for it. And it's very fast. You all know how long time it takes to boot a virtual machine? You know how annoying that is to wait for? So booting up your VirtualBox to work on something in cloud, and you have to wait like 3 minutes for it to just for it to start. Docker containers are pretty much instantaneous. They are very fast. You just start it up. Like the thing that takes a long time to do is to build the container, but once you've done that, you have the image and you can just like instantiate it. Yes. Another, yeah.
Could you explain what are the images?
Oh, sorry, I haven't even said that yet. Yes, Docker. Like you have your project and you want to Dockerize it. You write a Docker file, and that's instructions telling Docker how to build your image. And then your image is this blueprint that's built about how your like a Docker container will look like, and you can then instantiate that image into a container which will actually run your code and like your environment. Yeah.
The container, is that a binary blob that's executable? That Docker can execute?
I'm not sure how Docker does it under the hood actually, but I assume so. I assume they have it as a binary file. I don't see why they have it as an ASCII file. Yeah.
And some of the idea with the containers is they only contain exactly the services or the dependencies you need. They don't include anything else, and they also really only run one process. So you get a small image because it doesn't have a lot of bloat, like other
Right.
system Linux features that you don't need, for example, for your application.
Yes.
Doesn't have to be included in the image.
Another thing to add on top of that that I almost forgot is that images don't only contains like the changes from the previous ones, because you're gonna stack them on top of each other. So you start with, for example, your operating system, hopefully. So you have, well, I want to have like an Ubuntu one, right? And then I want to have like I don't know, some other like MongoDB on top of that. Like the MongoDB image will probably have an Ubuntu in it or some other Linux distro, and then when you make an image, you only keep like the changes you make. So you don't keep everything else. You only do the changes. Like same way Git works, right? You don't make a copy of the entire repo every time you commit something. You just store the changes, right? Compatibility is another point. It's just very easy to deal with compatibility with Docker because Docker just takes care of it. It just installs all its dependencies and yep. So when you have a Docker image, you're pretty much guaranteed you can run it on any system. Yep, that's pretty much it. So when you're running a Docker container, you can run this hello world example. There's tutorials on Docker's GitHub. They're very straightforward and yeah, nice to use. You can just say Docker run hello world. You'd think that would give you an error because you don't have anything named that. But it just pulls it from the repository, like the Docker hub. I think this one pulls it from. Yeah, and it will just rebuild it and execute it then. So same way about like if you want something more advanced, right? You want Alpine, just like a Linux distro. You say I want Alpine, and I want to run this command ls-l once I've started it up. Yep. So you download the thing with Docker pull. Oops, no, stop. Yes. You download the thing with Docker pull and then an image. If it doesn't exist, you probably need to go Google it and find out what exactly the name is. You can go on Docker Hub at the bottom, which I moused over to hide it. There. Docker Hub to find images. You can then pull them, you can then run them, and have a nice image. Right. Oh, yeah. If you want to actually open up a terminal in this, you can do bash. So you can open /bin bash and do the -it flag, which I think just makes you able to run it. I don't remember exactly what the flag does.
I think it stands for interactive or something like that.
Probably. Yeah, I tried to open the help menu, but it didn't list the flag. I was like, what? It's not here? But yeah, interactive. Makes sense. So building your own container, you probably just don't want to just download made images because that wouldn't be very useful to you. But you can just make your own then. So that's why you need the Docker files. You need to make your images. So just the hello world example, it's also, by the way, as text in the slide description, so I'll upload this, and if you want to test it, you can just copy the text instead of writing it, because it's an image. Yes. Yeah. You just say from. You always have to have the from keyword, saying from what existing image do you make this. You don't start off with nothing. And then what work directory inside that image am I making this project? Where am I making this image inside of the container? So you might want to put it in a specific location. Often you can just put it in root, right? Because no one's actually going to use the system. No one's going to be hopping around in there, so it doesn't really matter. You might want to copy all the files that you want to have in there. So this is all an example, by the way, from again, I need to stop mousing down there when I want to talk about it. This is just a very nice example from what was it, Calico or something. Link is also in the slide and in the example files. Yeah. So you copy all your source files. In this case, that's pretty much just main. And you say, well, once we're in there and we've copied all our files, we want to build it somehow. So add instructions with the run command. You can have as many of these as you want, and they can do pretty much whatever you want. And then lastly, tell Docker how to run your thing. So you might want to, you might want to have start parameters. You might want to like run several things first. Then you do that with like the CMD keyword. Yep. So we can actually go and do that. So we have the example here. I don't know why I didn't just show this. Right. So here's our file. Link to it. And we can build it with, do I even have it here? Yeah. Yes. So I can make this a bit bigger. There we go. So we build it with sudo docker build -t, and then the -t flag is just give it a tag, give it a name. We want to actually have it something and not just have it as a random string or even just a blank thing without a name. So we build this, and this the process that takes a little bit of time. So I think I already have this built. Or I might have removed it. So if you already built it and just build it again, just uses the cache, and then it doesn't do all the work again. Right, it's done. Sudo docker run. And I want to run this thing. What's it called? Hello? Docker. Unable to find image locally. What? What did I call it? Oh, hello world. And it did the thing. Yay! Yes.
So what was the command dot what do you have main to start with?
Yes. So here we say /main. So we create our binary executable in Golang by running the command go build. That creates our binary, and then we tell it to run this. So we want to actually, we want to execute the binary file named main in the directory, like in the working directory where our app is. So when we set working directory, you cd into it, and then copy our main file, our main.go, and then build it with the go build. That gives you the executable, and then we execute it with the cmd, the /main. Same way you would have done if you just executed it on your machine locally. You would just said /main to execute the executable. Yep. So that prints. Oh, that's the wrong thing again. So that executes your hello world example. So that's everything there is to it. It's simple. Though it gets more advanced when you have. Oh yeah, I forgot to add a slide for that. Oops. It gets a little bit more advanced when you have networking. Not a lot though, just a little bit. So I have this very simple program. Yeah, that's big enough. It does just the same thing, but with a not a webhook, a web handler. So when I start the application, it says starting a service. I define a I keep saying webhook in my head. Handler. And then I bind that like port 8080, or say that I use port 8080. Yep. And it just prints hello world to the thing and says in the terminal, oh, by the way, we handled a user. Normally you might want to have a logger or something to actually keep track of these things. But Docker file, very much the same thing. We have from what image we're using, go to this directory. We want to actually make it somewhere. And then copy our source file, compile our source file, and then the new part. We want to expose our port because we actually want to be able to, talk to this thing. And if you don't specify anything, none of the ports will be open to the Docker container and you can't talk to your app. So you expose your port and you can talk to it. and then same thing, run it. So if I do this again, I hope I have this built, because I don't want to run it again. So again, you say, you know, sudo docker build, but that takes a little bit of time. Oh wait, I think I actually removed them all. I think I do have to build again. Got that. Cocker. Yep, -t, web, hello. Yeah, I think that's it. Yes. Pretty much all the commands in Docker sudo. Oh, I already had it. Amazing.
You can just add your user to the sudo root and then
Yeah, but that's work though.
One command from the Docker documentation.
then you don't have to write the password. Okay.
Yes, but I feel like it's more secure when I write my password every time, even though it's not really. People can't just go on my computer and delete my root directory, right? But yes, anyways. Now we have it built, we can run it. So, sudo docker. So, is someone keeping track of how many times and all the ways I've misspelled Docker? Just expect a list after this. That's it. Run, and you can add the detached flag. So, I mean, that's kind of low on there. Can I make it? Okay. Anyways, you can add -d to run it in detached mode. This makes it so it will run in the background and just kind of do its thing until you kill it or it crashes. So, yes. I'm not going to have -d because I actually want to see the output in my console. So, and then, what do I call it, web, hello. And I've forgotten something already. So, just for the sake of it, we'll go to the thing anyways. So here I have the example. If I just go to copy this, go to Google first, and then do this again. What did I forget to do? Yes, I forgot to specify what port I'm running the app on. So if you remember, I exposed the port 8080 in the Docker container. So the Docker container expects information to go through port 8080 for my app, but when I ran it, I actually need to specify where, like, if I want this port to bind to some port on my system, because you know this is supposed to be its own operating system with its own networking, and I need to bind my port 8080 to the Docker the Docker container's port 8080. Yep.
The Docker has a separate network in itself.
Yep.
So it's running perfectly fine.
Yeah, it's running perfectly fine, but I can't access it, which is the problem. Yeah, it is running. Like we can see it like starting service and it's just sitting there waiting, but it's never going to get a request. So, what? Is this not it? This worked yesterday. Okay, there we go. Just takes a bit of time, I guess. So we add our -p. So 8080 binds to 8080. So this is the same thing you might have seen in Docker Compose files if you have had a look at them, where you say this port equals this port, pretty much. So now if we run it, any day, what? Failed. Context cancelled. Executable file find in what? Do I need to have the flag before it?
No, I think so.
Okay. Alright. Nice. So now if I try and reach it, it works. And I say hello world. And greeting user twice for some reason. Yeah, that's pretty much it. So exposing ports, reaching your service. Yeah, pretty much it. So some useful commands. You can... No, sorry.
Just a comment to the ports thing. The good thing is there you can actually specify the ports that you wish to use as well. So you can have port
Yes.
80 to 8080.
That's true.
So you can use whatever ports you want.
Yes.
Just map them to each other.
Yeah, and you can map it to different ports as well, right? So you can have 8080 on the in the Docker map to, for example, port 5000 on your machine, because it might be taken. Yeah.
If you don't want to bother with allocating ports manually, you can just use -P, and then you just assign random ports on your local system, or random ports, and you can view the ports you assign using Docker PS.
Okay. Right. So then, yeah. Yep. Absolutely. Because
For
here.
testing networks.
Yes. Yeah, that makes sense. Good tip. So just minus, you have colon, then minus, and then just fills it in.
Just
Just a capital P.
Just capital P. Ah, right, right,
Just
right.
those ports.
Okay. Nice. Right. So we saw this sudo docker build. You'd say, I want to build this thing, and dot there. It's kind of hard to see, but there's a dot saying this directory. Yeah.
I didn't understand. What happens if you have different ports
Right. If you have different ports on your Docker in your Docker image and your like real computer, well, it's just a way to like route the networking, right? Because your app sends its data to like port 8080, and then it expects that to be open, right? It expects that to it expects you to reach it through that port. So yes.
It's gonna be sort of if you've done any like port forwarding to the
Yeah.
It's almost like at the router, for example, you can say that I want this port from the outside to go to this port on the inside.
Hmm.
And
Yeah.
then just tell Docker that this port on the host machine goes to this port in the Docker port.
Yes, because for example, port 880 might be like occupied, right? Port 880 might be already in use on your actual machine, so you can map it to, for example, port 5000 by saying, 5000 colon 880 if that's the right order. Yeah. Yes. But yeah, you build it, give it a tag, so you want to get a name on the thing. It expects a Docker file in that folder then to explain it how to build the image. And yes, Docker run, same thing. You give it an image, and then you can add -d to run it in detached mode. Again, detached mode is just running it in the background, so it does its own thing. You can then stop it with sudo docker stop and then the image. And you can list all the running, all containers with sudo docker ps. And you can add -a flag to see all of them if some are like hidden. You can do the same with images. You can list all the images and see the images. You can also RM the images. So you make an image, say you want to do it clean again, you want to like remove it and then rebuild it. You can do sudo docker rm and then the image name or ID. So just to give you an idea what that looks like. Oh, again, almost did it again. Right. So right now I have one image. No, one container, I mean. Yep.
Can you have multiple Dockers running at the same time with different operating systems and have them work together?
Yes. You can absolutely have one Windows container running and then have another Linux container with your database and have both of those on your same machine.
And then you just run, and then how do you say run this one and stop this one?
You can use Docker Compose for multi. You should use Docker Compose for multi like stage builds for that, like that, where you have several images working together and like one might depend on the other, like your web service might depend on your database. Yeah.
So the reason why we would want to use Compose or Swarm to do that is because of the internal network, to create one network for both of the containers, as the same as they have there. With the 88 is only on the inside, which is their private network, but when you have multiple containers, then you would compose them together with a network so they could actually speak together. And then they work just like a regular network, just on the inside, and you expose only the ports that you want to use.
Yep. So do you know what Docker Compose is? Yeah, Docker Compose is this this tool you can use to build all these things here like automatically. So you make a Docker file for a container or for an image, and then you make another one for another image, and then you have your Docker Compose file, which kind of tells, it just tells like Docker Compose how to put it together, like how do we stitch these images together into like one service, and then it'll then you say Docker Compose up, and then it will like spool up all of them in the right order and like hook them together so they work. And in that compose file, you specify things like ports, credentials. You don't actually specify the credentials, you use an environment file. Yeah, that's one thing I forgot. I had it in here, but I forgot to actually talk about it. Here. You don't put your credentials into your Docker file. You don't copy like, or you don't have, say, like export and then my like database password in your Docker file. You just say use this environment file, and then you like use this variable in Bash, and then use your environment file to specify that variable, because you don't push that to your repository, and yeah, you just have that in your setup instructions that you need to do that. Yeah.
Yeah, even though you built an image and you push it to like Docker Hub, anyone that downloads it can go and see exactly what you put inside it. So if you have put some code in there you don't want others to see, then don't put it in a Docker image in the first place. At least don't push it somewhere. Don't put your Firebase credentials in your Docker image and push it. This is something you should add after you're running. For example, like mount a folder on your or your environment variables.
These were one of the many vulnerabilities in the previous assignment that was kindly pointed out. Yep. So yep. Don't put credentials in your Docker file. Use variables, and then specify the variables using environment variables in Bash. Yeah, that's what that looks like. I don't have anything other than that. So yeah.
Does Docker load the environment variables itself? Because I had a problem with using sudo to get using port 80. The environment variables were overwritten, and it was
Oh.
You have to specify them like command line.
Yeah.
Hmm.
When you run the Docker.
When you do Docker run, and then just have a flag for specifying all the environment variables.
Okay. Yeah, that's pretty much it for me. So, how many of you have found a group for the project? Yes. How many haven't found a group for the project? Alright. Nice. So, does everyone know what they want to do? At least a little bit, yeah. Alright, not all of it. So, yeah, do put like your project ideas into the wiki, and Christopher will have a look at them and see like whether or not they are actually like feasible. You can ask me as well if you wonder if something is big enough, if like it's acceptable to do this kind of technology. Like, do feel free to like explore anything. Like, if you have some technology you want to try out, do it by all means. We only have like the minimum requirement that it is, that it fulfills the minimum requirements, that it's doing some of these things. But if you want to solve the minimum requirements with some technology you haven't touched before, do feel free to do that, absolutely. Yep. So yeah, that's pretty much it. I don't have anything else. So I mean, there's no assignment running now. By the way, if you didn't catch it, the wiki was updated yesterday, I think, with the deadline for the project, which will be the 22nd. Yeah. All right. Thanks.